Alright, picking up where we left off from the last video. Okay, we were right here, and the last thing left to do to get x by itself is to add 5 halves to both sides. Alright, so again, leaving your answer in square root form is the best way for math people, because we like things to be exact, but you can type it in the calculator and get an approximation as well. Okay, so what we have here, I'm actually going to move this 5 halves to the front. It's 5 halves plus or minus. Okay, and then remember our rule, we're not allowed to have a square root in the denominator. We currently have that. But this one's a lot easier because you can just split this up. You can do the square root of 13 on the top. And then on the bottom, you can do the square root of 4. But the square root of 4 is a perfect square, so that is equal to 2. Alright, so you can leave it like that. If you notice that the two fractions have a common denominator, you could even combine these together. 5 plus or minus the square root of 13 all over 2. Alright, and then like I said, you could also type this in. You'd have to do it in two separate parts. 5 halves plus the square root of 13 over 2, and 5 halves minus the square root of 13 over 2. And that would give you the two decimal approximations of the answer. Alright, which is what you would have gotten from the calculator method. This secondary form is what we would have gotten from the quadratic formula method. So all the methods obviously will produce the same answer, alright, as long as all the rules were followed correctly. Alright, let's take a look at this second quadratic equation over here. So like I said, the first option for us, the easiest option, is going to be to factor. Okay, so let's see if we can factor this one. Alright, so this one's not going to be just simply x times x, because we have a 2x squared. Okay, we can't take this 2 out either, like a GCF, because these numbers, this is a 1, this is a 1, they're not divisible by 2. Okay, so we got to leave it as is. Okay, so that means one of these is going to be a 2x, and one of these is going to be a 1x. Alright, now we have to figure out what numbers multiply to equal negative 1. Okay, so I'm going to do similar to like I did in the last one. There's kind of two options here. Negative 1 times positive 1. Okay, that multiplies, or positive 1 times negative 1. Alright, and that works. Okay, now if you kind of think of this as a FOIL problem, you can figure out which one's going to add up to negative 1 in the middle. Okay, so this 2x would multiply by this term if we were doing FOIL. So 2x by positive 1, that'd be positive 2x. And then this x would multiply by this term, which is negative 1, so that'd be negative x. And what does those two add up to? Positive x. Is that what we wanted? No. So that's wrong. Alright, what about this other one? 2x would multiply by negative 1, so that's negative 2x. And x would multiply by positive 1, so that's positive x. What do those add up to? Negative x. Is that what we wanted? Sure is. So this one does factor, 2x plus 1, x minus 1. Okay, once you have the two factors, you're not quite done yet. You need to set those equal to 0 and solve for x. Alright, so this one we subtract 1 and divide by 2. So we get x equals negative 1/2. And this one we add 1 and get x equals 1. Alright, and those are the two solutions to our problem. Alright, next type. This one is fairly easy to see what's going on here. You see where the x is located, so we identify what type of equation. X is inside a radical, so this is a radical equation. Alright, so the radical equation, we went over these more recently, at least in the second semester, since we've been back from Christmas break. Okay, so to solve a radical, we're trying to get x by itself, we need to isolate the radical first. Okay, so it's similar to solving for x. You want to isolate x normally, but we can't just jump straight to that. We have to isolate the radical first. So we're going to add 3x to both sides. This gets my radical by itself. And then that's 3x plus 1. We can't add those together. They're not like terms, so we'll leave it like that. Alright, now we can actually cancel out the radical, which is our kind of our first goal of this problem. So we're going to square this. Now, when you go over here, see how it's two terms? you can't just square each one separately. Okay, you have to square this whole thing as a whole, like that. Okay, and that's going to be kind of a theme with this whole squaring thing to get rid of our radical. So this is x plus 1. The radical cancels out. But over here, we have to do some FOIL, or window pane. Okay, so 3x plus 1 again. So 3x times 3x is 9x squared. Okay, that's 3x times 1, so 3x, and then another 3x times 1, so another 3x. Add those together, and you get 6x. And then 1 times 1 is 1. Alright, so this is a type of equation where we're solving it out, and now what type of equation do we have now? Alright, well now I see an x squared here, so I know that this is now a quadratic equation. So let's use what we learned on the last page and try to solve this one out. So we need to get it equal to 0 as our first step. You can't solve a quadratic if it's not equal to 0. So subtract x and subtract 1. Now that'll cancel both of those out. That'll happen over here. So we'll get 0 equals 9x squared plus 5x. And the 1's cancel, so that's it. Alright, so like I said, the easiest way to solve these most of the time is factoring. Now, it doesn't work for every problem, okay, but we always want to start there. We can do another method if we need to. Alright, this one does factor. Okay, since it's missing that last term, it's not a traditional factoring, like not going to get 2 parentheses, but we can see that they have something in common. They both have an x. So I can factor out an x like this, and that'll leave me with 9x, one of those x's went away, plus 5. And now you can solve this equation by setting this x we took out equal to 0. So 0 might be one of our answers. And then set 9x plus 5 equal to 0. And this one we have to do a little solving. We subtract 5. We divide by 9. And you get x equals negative 5 ninths. Alright, now you might have noticed when I said x equals 0 might be one of our answers. The reason is with square root equations and really any other type other than just a linear or just a quadratic, you need to plug them back in and make sure they actually work. Okay, so I need to plug 0 back into this original equation, make sure it works. So we're going to use the calculator for this part. Alright, so I have the square root of now 0 plus 1 minus 3 times 0. And then when I hit enter, this needs to equal 1. Alright, good to go. Alright, now if you arrow back up, we can hit enter and copy that down. Now I just need to change these zeros to negative 5 ninths and see if that works. So we'll delete that. We'll do negative 5 divided by 9. And then I'll come over here and delete this one. And same thing, negative 5 divided by 9. Alright, and you'll see that when we do that, you do not get 1. So negative 5 ninths is not a solution to this problem. So that's called an extraneous solution. We have to cross that out. And x equals 0 is the only answer that actually works. Alright, our next type, you'll see that the x is inside an absolute value bar. Okay, so this is going to be your absolute value equation. Alright, if you think about what absolute value means, we talked about this a really long time ago when we first did these. But absolute value means that it's the distance from 0. So if I say what points on the number line are 3 units away from 0, you would say 3 units to the right is positive 3, and 3 units to the left is negative 3. So there are 2 answers to that problem, positive 3 and negative 3. So in that line of thinking, there are going to be kind of 2 different ways to solve this out. Alright, absolute value of x equals this. Okay, so that means that x equals positive this whole thing over here. And that's basically the problem written before you. Or x equals the negative version of that, x squared plus x minus 3. Alright, so we have 2 different equations we need to solve. Alright, now you'll notice both of these equations are quadratic equations. They have x squares. Okay, so we need those to be equal to 0, so I'm going to subtract x from this one. All right, and that's going to give me 0 equals x squared. Those cancel out, so minus 3. All right, and then over here, you're going to have to distribute that negative into all three of these. So that's going to be x equals negative x squared minus x plus 3. And then subtract the x. 0 equals negative x squared minus 2x plus 3. Alright, and then each one of these is going to get solved. Alright, this one is a little bit simpler because we can actually just get x by itself. We don't have to do a factoring. First of all, it wouldn't factor because we're missing that middle term. And 3 is not a perfect square. If it was a perfect square, it would factor. But since it's not, we can't. So we just move that 3 over. So that's x squared equals 3. And then you can square root. And then remember your plus or minus in front. And that'll give you two possible answers, plus or minus the square root of 3. Over here, we do have a full quadratic with all three terms. Don't like the x squared to be negative, so I'm going to just start by multiplying this whole equation by negative 1. Alright, so that's x squared plus 2x minus 3 equals 0. And then let's see if we can factor this. So that's going to be x times x. And then numbers that will multiply to equal negative 3. So I have negative 3 and positive 1. Or it could be positive 3 and negative 1. Do either one of those add up to positive 2? Yes, positive 3 and negative 1. Which leads us to our two other answers. X plus 3 equals 0 and x minus 1 equals 0. So x can also equal negative 3 or positive 1. Alright, now again, like our last problem, we have to check and make sure that these work. Okay, so we're going to type these, plug them back into the original problem. Alright, and see if we get what we wanted to. Alright, so to get an absolute value on the calculator, you press this little button. It's right here next to the 9. It's a template button, and absolute value is one of your choices right there. So absolute value, and we'll try square root of 3 first. Alright, and we'll just do that. And then on the other side, we need to equal the square root of 3 squared plus the square root of 3 minus 3. Alright, those equal the same thing. So that's good to see. Alright, let's see if that works for the negative square root of 3. Alright, so if I enter this down, I just need to put a negative in front of it. Alright, and to be expected, that equals the exact same thing as the positive, because the absolute value cancels out the negative, basically. Alright, so let's see if our other one up here gets the same thing. So I just need to put negatives in front of these square root of 3s. So I'll put a negative there, and then same thing here. See, that one doesn't work. That adds up to the negative 1.73. Okay, so the negative square root of 3 is extraneous. So we just cross that out. Alright, let's try it again with the negative 3. Okay, so we have the, I'm going to just retype this now. Alright, absolute value of negative 3 is positive 3. And then we have negative 3 squared. So you got to put that in parentheses when it's a negative number. Otherwise, you'll get the wrong answer. So negative 3 squared plus negative 3 minus 3. Yep, that one works. Alright, one more. Let's try positive 1. See if this one works. So absolute value of 1 is 1. And then it's 1 squared plus 1 minus 3. And that one doesn't work because that's a negative 1. Okay, so 1 is extraneous. So x equals square root of 3 and negative 3.